Welcome to the deep dive. Today we're going on a global expedition from the comfort of our chairs.
Yeah, without even leaving the studio.
Exactly. And all thanks to some incredible high-resolution maps.
That's right.
You've shared a research paper comparing the latest in land cover mapping
Yeah.
that kind of can identify individual trees and fields from space.
Yeah, it's amazing what these maps can do now.
It's pretty remarkable. The paper focuses on three big names: ESA's WorldCover, Dynamic World from Google and WRI,
Right.
and ESRI's Land Use Land Cover Map.
Yes.
And you want to know which one comes out on top, right?
Of course. That's the question everyone's asking.
Which one is giving us the most accurate, the most detailed, and reliable view of Earth's surface?
That's the goal, isn't it?
Yeah.
But before we get into that, it's worth taking a step back and appreciating just how important these maps are.
Okay, let's do that. Why should we care about accurate land cover maps?
Well,
Especially at such a high resolution.
I mean, think about it.
Yeah.
Imagine you're a conservationist trying to protect a fragile rainforest.
Mm-hmm.
These maps can literally make the difference between catching illegal logging early or losing huge amounts of forest before you even know it's happening.
Wow.
Yeah.
Hadn't thought about it like that.
Yeah, it's like an early warning system
Yeah.
for the entire planet.
Okay, so it goes beyond just conservation then.
Oh, absolutely.
How so?
These maps are vital for everything from managing resources and planning sustainable cities to predicting disease spread and responding to natural disasters.
I see.
Having accurate information about what's actually on the ground is essential for making good decisions.
So it's not just about pretty pictures from space.
No, not at all.
It's about having actionable data.
Precisely.
Yeah. Okay, so we're talking 10-meter resolution here.
Yeah.
So we're seeing an incredible level of detail.
Oh, yeah.
We're not just seeing blurry patches of forest or urban areas anymore.
Nope.
We're seeing individual trees and buildings,
That's right.
even agricultural plots.
It really is mind-blowing.
That's incredible. Okay, so let's meet the contestants in this map showdown. We have WorldCover,
Yes.
Dynamic World,
Uh-huh.
and ESRI's LULC.
Okay.
What are their superpowers? What makes each one unique?
Well, each one has its own strengths.
Okay.
WorldCover from the European Space Agency uses both Sentinel-1 and Sentinel-2 satellite data.
Oh, interesting.
So they're combining radar and optical imagery.
To create a richer picture.
Exactly.
Why use both types of data?
Well, radar can see through clouds and darkness,
I see.
which is crucial for monitoring areas that are often obscured by weather.
Makes sense.
Optical imagery, on the other hand,
Yeah.
provides more detailed information about colors and textures,
Mm-hmm.
which is helpful for distinguishing between different types of vegetation.
Okay, so it's kind of like getting a multi-dimensional view then.
Yeah, that's a great way to put it.
So how do they actually analyze all this data?
So WorldCover uses something called a gradient boosting decision tree model.
Okay.
It's a mouthful, I know. But essentially, it's a powerful machine learning algorithm
Okay.
that can analyze massive amounts of data
Mm-hmm.
to identify patterns and predict what each pixel represents.
So is AI doing all the heavy lifting?
You got it.
Trying to figure out if a pixel's a tree or a building or a puddle?
Exactly. And based on their initial assessment, WorldCover claims a global accuracy of around 77%.
Not bad.
Not bad at all.
Okay, so that's WorldCover. What about Dynamic World?
So Dynamic World is a collaboration between Google and the World Resources Institute.
Okay.
They take a slightly different approach.
How so?
They only use Sentinel-2 data,
Okay.
so they're focusing just on the visual spectrum.
I see.
But their secret weapon is a fully convolutional neural network,
Huh?
basically a super sophisticated image recognition system,
Okay.
specifically trained to identify different types of land cover.
So Dynamic World is all about those visuals.
That's a good way to put it.
High definition.
Yes, and they pride themselves on providing near real-time updates. Yeah, which
Nice.
is really valuable for monitoring rapidly changing situations.
For what?
Like deforestation, floods, or even wildfires.
Oh, wow. And they're reporting a global accuracy of...
About 74%
Okay.
globally.
So 2 down, 1 to go. Bring on the champion, or at least the contender who claims to be the champion.
Let's.
What about ESRI's LULC map?
All right, so ESRI also uses Sentinel-2 data,
Okay.
and they rely on a convolutional neural network,
Uh-huh.
but a specific type called a UNet model.
Yeah, a UNet model.
Yeah, think of it as a specialized neural network architecture
Okay.
that excels at image segmentation,
Meaning?
breaking down a picture into its individual components.
Ah, so it's like they have a digital artist who can color in all the different areas of the map?
Yeah, that's a great analogy.
perfectly.
And ESRI is coming in with a claimed global accuracy of 85%,
Wow, okay.
the highest of the three.
So we've got a pretty close race here.
Yeah.
But before we crown a winner, based just on these reported numbers, this study dug into something really important. The uncertainty in the reference data that's used to validate these maps.
Yes, that's a crucial point.
Can you explain that a little? Why does it matter?
Sure, so even something that seems simple,
Like what?
like labeling a pixel as forest, can actually be tricky.
How so?
Well, what happens when you have a mix of trees and shrubs in that pixel?
Ah, I see.
Or what if the satellite image is slightly misaligned with the actual location on the ground?
Yeah.
So these uncertainties in the reference data can really skew the accuracy assessments.
So one map might appear better than another
Yeah.
simply because it was validated against a different set of data.
Exactly.
So it's like comparing apples and oranges.
Exactly. We can't just take those accuracy numbers at face value
Yeah.
without understanding how they were measured.
Right, and that's where the 5 validation approaches used in this study come in.
Yes.
They wanted to see how different ways of dealing with this uncertainty would affect the results.
Right. It's like they're stress testing the maps. To see how well they hold up in the face of imperfect data.
Okay, so they're putting these maps through a series of challenges then. They
Exactly.
see who comes out on top,
Right.
like a reality show for maps.
I like that.
And they use different approaches, ranging from a super strict direct comparison to more lenient methods
Yeah.
that allowed for alternate labels or even filtered out areas that were too mixed or heterogeneous.
Yeah, they wanted to cover all the bases.
So what did they find?
Well, the interesting thing is
Yeah.
how much the accuracy estimates varied depending on which approach was used.
Oh, really?
Yeah, it was pretty surprising.
So after putting these maps through all these different validation methods, did they find a gold standard approach?
Well, it's hard to say if there's one gold standard,
Yeah.
but they did find that one method seemed to be the most balanced.
Okay.
It involved using the direct label for each pixel, but also taking into account the majority label of the surrounding pixels.
So they're like looking at the neighborhood
Ex-
to get a better sense of what that pixel should be.
Right. It's like taking a majority vote
Oh, I like
from the
that.
surrounding area to smooth out any potential errors or inconsistencies.
So if a pixel is labeled as grassland, but all of its neighbors are forest,
Right.
maybe it should be forest too.
Exactly. It's a way to acknowledge that there's uncertainty,
Yeah.
but without being too strict or too lenient.
It seems like a pretty smart approach.
Yeah, I think so.
Okay, so based on this majority vote method,
Uh-huh.
what happened?
Well, the results got interesting.
Did they?
Remember how ESRI was claiming the highest accuracy?
Yeah, they were at 85%, I think.
That's right. But after this more nuanced validation,
Yeah.
WorldCover actually came out on top
Oh, wow, a plot twist.
with a global accuracy of 83.8%.
WorldCover, the underdog pulls ahead, but I'm sure there's more to the story.
Of course, there's always a but.
Right.
WorldCover might have scored highest overall, but remember, accuracy varied depending on the region and the type of land cover.
So it's not a one-size-fits-all situation.
Right.
Like with athletes.
Yeah.
The best overall athlete might not be the best at every single sport.
Exactly. So let's look at how each map performed for different land cover types.
Okay.
That's where things get really interesting.
I'm all ears.
So for basic categories like water and trees, accuracy was pretty high across the board.
Makes sense.
They're pretty easy to distinguish.
Yeah, a lake is a lake, a forest is a forest.
Right. But it gets tricky with categories like mixed vegetation or crops or bare ground.
Yeah, I could see that.
Those are harder to distinguish from satellite imagery.
Yeah, trying to tell the difference between a field of wheat and a meadow from space.
Exactly. And that's where we see some interesting patterns.
Like what?
Well, WorldCover did well with mixed vegetation,
Okay.
which makes sense because they're using both radar and optical data
All right.
to get a more complete picture.
So they're better at figuring out those complex landscapes.
Yeah, exactly. But Dynamic World tended to overestimate bare ground, often mistaking it for other types of sparse vegetation.
And what about crops?
All three maps had trouble with crops.
Oh, really?
Yeah, often confusing them with mixed vegetation.
So mixed vegetation is like the junk drawer of land cover types.
That's a great way to put it.
It's where everything that doesn't have a clear category ends up.
And it highlights why clear definitions for these categories are so important.
So it's not just about the technology then.
No.
It's about making sure everyone's speaking the same language.
Exact.
Okay, so we've talked about accuracy and we talked about those 10-meter resolutions, which allow us to see incredible detail.
Right.
But this study also looked at how well each map captured that detail. So we're going beyond accuracy. We're looking at how much nuance they're picking up.
That's right. They use this idea of homogeneity levels to measure how much variation there was within a small area on the map.
Homogeneity levels.
Yes, basically they looked at a 3x3 grid of pixels and calculated how many of those pixels had the same land cover type.
So if all the pixels in that grid are the same, that means it's a very homogeneous area.
Yes, like a golf course.
Yeah, exactly. But if there's a lot of variation within that grid,
Right.
that means it's more heterogeneous.
Like forest.
Yeah. Okay, so what did they find?
Well, despite all having the same 10-meter resolution, the maps were very different in their ability to capture that level of detail.
Interesting.
WorldCover consistently showed the most heterogeneity, meaning they were picking up on those subtle variations that the other maps were missing.
So they're seeing the nuances, the little details that tell a more complete story.
Exactly. And this difference in detail comes down to the data and methods being used.
Right.
WorldCover's use of temporal information.
How things change over time.
Yes, that helps them distinguish between areas that might look similar in a single snapshot.
So it's like they're watching a movie of the planet
Yeah.
while the others are just looking at still photographs.
I like that analogy. And this difference in detail is really obvious when you look at the visual comparisons in the study.
Okay.
For example, they show an area on Long Island where WorldCover clearly shows the individual fields and roads and even small patches of forest.
Wow.
While the other maps are much more generalized.
So in this map showdown, WorldCover is the overachiever.
It seems that way.
Super accurate and incredibly detailed.
Yes, but to be fair, the other maps also had their strengths.
Oh, okay. Tell me more.
For example, Dynamic World excelled in mapping built-up areas.
Urban areas.
Yes, especially in North America.
Okay.
Which makes sense given their focus on those real-time updates.
Right.
Because cities are constantly changing.
Yeah. And what about ESRI?
ESRI was surprisingly good at mapping mixed vegetation in Oceania.
Okay, so each map has its strengths and weaknesses.
Yeah.
Its own areas of expertise.
Right. It's like rock, paper, scissors.
Yeah.
No one map dominates in every situation.
That makes sense. So the key takeaway here is...
Well, you have to understand the nuances of each map.
Yeah.
To make good decisions about which one to use.
Choose the right tool for the job.
Exactly. And that's where the study's insights into national level accuracy are useful.
Okay, how so?
They found big differences in how the maps performed in different countries.
Even within the same land cover type?
Yes. For example, WorldCover was highly accurate in Iran, but ESRI's map struggled there.
So location matters?
Yes, a lot. And the study also highlighted areas where all the maps struggle.
Oh, really? Where?
Places like Mozambique, Tanzania, Nigeria, even parts of Spain.
Oh.
These are areas with a lot of diversity and rapid land cover changes.
So even with AI and all this data,
Yeah.
there are still some areas that are tough to map accurately.
It's true, and that's what makes this field so exciting.
It's a challenge.
Yes, there's always room for improvement.
Okay, so we've covered accuracy detail,
Yes.
the good, the bad, the blurry. What about the future of land cover mapping?
Well, the future's all about dynamism.
Ooh, dynamism.
Imagine maps that update in near real time.
Are we talking like live streaming planet Earth?
Not quite live streaming, but close.
Okay.
Dynamic World is already doing this to some extent. But imagine combining that with even higher resolutions and more sophisticated AI.
Wow, what would that allow us to do?
We could track deforestation as it's happening.
Wow.
We could monitor crop health in real time.
That's incredible.
We could respond to natural disasters much faster.
It's like having a finger on the pulse of the planet.
Exactly. But we still have those limitations we talked about.
Right, like the inconsistent definition.
Yes, that's why standardization is so important.
So everyone's on the same page.
Right, a common language for land cover.
Okay, so it's like creating a universal translator for these maps.
Yeah, that's a great way to think about it.
And that's just the beginning.
It is. The possibilities are endless.
Yeah, it feels like we've only scratched the surface here.
I agree. This has just been a glimpse into the world of high-resolution land cover mapping.
Yeah, and the technology is only going to get better.
That's right. Who knows what we'll be able to do in the future?
Maybe these maps will even be able to tell us where the best hiking trails are.
Or which vineyards will produce the best wine.
That would be amazing. But seriously, these maps have so much potential to change how we understand and manage our planet.
I agree.
It's a really exciting time to be working in this field.
It is.
So after this deep dive,
Yeah.
what stands out most to you about these maps and their potential?
That's a good question.
What further questions do you have?
Lots of them.
Think about it, and maybe we'll deep dive into those questions next time.
Sounds good.
Until then, happy mapping. This study focused on comparing these 3 global maps.
Right.
But I'm wondering about the potential for more regional or even local insights. Could someone use these maps for a much smaller project?
That's a good question.
Like managing a nature reserve?
Yeah.
Or planning a park in a city?
That's a really interesting point, and it highlights one of the limitations of this study.
Oh, how so?
Their data wasn't really designed to look at accuracy at very localized scales.
So you couldn't just take those global accuracy numbers
Right.
and assume they'll be true for your neighborhood.
Exactly. That's why we need more validation at the regional and national levels.
So we need similar studies,
Yeah.
but for specific ecosystems or
Exactly.
even individual countries.
Even down to the county level.
It'd be like having a zoom feature on these maps.
Yeah, I like that.
We could see how well each map captures the unique features of a specific area.
Right, and that makes me think about another important point.
Oh, what's that?
We need more validation of how these maps track changes over time.
So not just the accuracy at a single point in time.
Right, because right now we're pretty good at that.
Yeah.
But how well do they track things like deforestation or urban sprawl over time?
Yeah, that's a big question.
Especially for people working in conservation or resource management.
It's like the difference between a snapshot and a movie.
Yeah, exactly.
We need to see the whole story.
And being able to track those changes accurately opens up a lot of possibilities.
Like what?
Well, we can measure the effectiveness of conservation efforts.
Okay.
We could predict urban growth or model the impacts of climate change.
Wow, it feels like we've only just scratched the surface.
We have. There's so much more to explore.
And the technology is constantly evolving.
That's right.
So who knows what we'll be able to do in a few years.
It's an exciting time to be in this field.
It really is. So after this deep dive, what stands out most to you about these maps and their potential?
Well, I think the biggest takeaway for me is that there's no one perfect map.
Yeah.
It all depends on what you need it for.
Choose the right tool for the job.
Exactly. And we need to keep pushing for more research.
More validation.
Yes, especially at those local and regional scales.
So we can really unlock the full potential of these maps.
Absolutely.
Well, that was an incredible journey.
It was.
Thanks for sharing your expertise.
My pleasure.
And thanks to everyone listening for joining us on this deep dive.
Until next time.
See you then.